Okay, this lecture comes to a very important point to the solar charge maximizing controller system. What is the common negative? What is the common positive? If you ask MPPT solar charge controller manufacturer, tell them I want the common negative solar charge controller, you will not get answer because there was no distinction before this solar charge maximizing controller come to the system. And they designed the MPPT solar charge controller. I just presume PV positive, PV negative will be connected to the solar array, and battery positive, battery negative will be connected to the battery bank you're going to charge. They don't have to tell you which terminal actually internally connected. As a matter of fact, the MPPT solar charge controller has two options. They use NPN or PNP, these transistors. Depends on what they are using, and then it will have negative size PV negative or battery negative physically connected in the machine, or they could have PV positive and the battery positive connected inside the charge controller. But they don't have to tell you that. So we have to find it out because that's very important. We cannot mix them up. And how do you find them out? When the power is off, like you just open up the package. You don't have to connect anything, and you use ohm meter. Use ohm meter to check PV negative terminal and battery negative terminal. If you see continuity there, the ohm meter sound, beeping sound, when you check the continuity, that will tell you that it's actually internally connected, PV negative and then battery negative. So you can assume that MPPT solar charge controller is common negative design. Okay, that's very important because we have to find this solar charge maximizing controller to match that common negative to match common negative. It doesn't mix them up. We don't mix them up to use because it will not work. So in common negative system, we can have all these terminals, solar panel negative and solar charge maximizing controller negative and battery negative, inverter negative, inverter this negative, all connected. Because this is all connected and PV negative, it's internally also connected. You do not necessarily to connect this PV negative terminal because it's already connected. In MPPT solar charge controller application alone, that has to be connected because the solar array will not form a circuit to charge the battery for the current to go through the MPPT solar charge controller because they don't have this commonly connected, bonded as negative terminals. But in our solar charge maximizing controller, we have this bonded, solid, negative terminals. So that conduct the current. It will help this PV system. You could also connect it, but it will not have any current going through it as long as this cable is sized sufficiently. So we define that. In a common negative solar charge maximizing controller system, the negative terminal of all these components, solar array, solar charge maximizing controller, there's a terminal there, it's called a battery negative, MPPT solar charge controller, battery negative. Inverter also has a battery negative. They actually all connected, physical connected. If you find you cannot connect, you have the voltage differences, it doesn't work. So you're causing shortage. So that's why we cannot mix them up with other common positive. But we still have an option to have a common positive MPPT solar charge controller in the negative system, but you have to make sure it's charging a different battery bank. We're going to talk about later, but that's make sure that you know how to figure out what is common negative, common positive. We just mentioned that you check continuity. However, when sometimes you have the solar array connected, battery already connected to the MPPT solar charge controller here. Everything's already connected. It's working. And again, you probably will have this two series connected strings. It's already working and it's charging that MPPT solar charge controller. You don't want to disconnect all those, and you just try to increase the capacity. You try to add more this solar panel, and you got the solar charge maximizing controller. You want to figure out this is a common positive or negative. Here's another thing you can check. You use voltage meter, ohm meter, multiple ohm meter. It works too. You check a PV negative terminal and battery negative terminal. You use the voltage lead to check that. If you don't have any volts here, that means it's already internally connected. That is common negative system. However, if you check this has a voltage, and the PV positive and battery positive, this terminal there has no voltage, that means that's a common positive system. You have to buy common positive solar charge maximizing controller to make it work. We're going to show you another slide to explain how it's different, how it is different from this connection. As you can see here, common negative, this negative is all bonded, connected. And the panel will look like so every strings here you have this negative all connected. And PS1 here is only an option. If you have 40 VDC solar charge maximizing controller system, you would have a solar charge maximizing controller which is a 40 AVDC system to match that, but that's an option. Now, you don't necessarily to have this connected to make a solar charge maximizing controller system. So that's the split wire we talk about. It's controlled by the solar charge maximizing controller, and the PV positive is still connected to the MPPT solar charge controller. So this is the common negative system design. We make sure that this will not be mixed with the common positive, because common positive solar charge controller cannot be used in the common negative this solar charge maximizing controller design. It's very, very important. We just mentioned you have two ways to find out the MPPT solar charge controller. It's a common negative or common positive design. However, there's another way here. For example, this is the cutout from the FlexMax Series 60 and 80 MPPT solar charge controller from Outback Power. You can clearly see the instruction menu give you instruction how to wire this system up. And then you can clearly see this is a common negative design. Why? Because this PV negative, battery negative, it's all get connected to the DC negative bus bar here. It has to be common negative design inside the MPPT solar charge controller. And the negative, it's also connected to the solar array. right? Solar array here. Connected to the solar array, this negative. And negative is also connected to the battery bank, 48 VDC battery bank. So all this is actually all negative, the bonded, connected, solid. Like they connect to the battery bank through the shunt, so it's kind of solid, all negative connect. So this is a 100% common negative design. And you can just find out from the manual book. For the voltage, as you can see here, this 60 or 80 is referring to this capacity of the MPPT solar charge controller. It means that you can get the maximum 80 amps or 60 amps going through the MPPT solar charge controller to charge the battery bank. So that's the capacity, but you also want to make sure the voltage, maximum voltage, because it will determine how many panels you can connect them in series. It's below 140 VDC. Some manufacturer asking for all different kind of voltage, maximum open circuit voltage, but FlexMax ask for 145 VDC. So for this model, you may also see other manufacturers give you maximum 60 volts, 80 volts, 100 volts, 150 volts. But as I can see here, this is a maximum voltage inside the transistor. Is a terminal VCE connector to emitter. That terminal has a maximum voltage, normally 150 VDC, and it's kind of conservation, some kind of for safety operation of the MPPT solar charge controller, so they limit it to 145. Make sure it's open voltage. It's an open voltage, not the operating voltage. So make sure that this transistor VCE not to be over voltage. Once that is over voltage, it can cause permanent damage to the MPPT solar charge controller. Other common negative design, we know that Renogy Rover PG series, you can have 20 amps, 30 amps, 40 amps. This Renogy, this Rover PG series design, but they only have 100 VDC maximum design. They are also common negative system. Like a grow ones with the charge MPPT charging controller inverter combination. Their MPPT solar charge controller can charge 80 amps, but they still also common negative design. You can check that negative terminal, battery negative terminal, PV negative terminal actually has same voltage. If you check that, it's kind of continuity inside. So you need to find that out first before you can determine what solar charge maximizing controller to use. Make sure common negative matches common negative. We cannot use the different one to charge the same battery bank. If you have some other this common negative design, not sure, can let us know. We'll figure it out, and we're going to post a list of the manufacturer's common negative design or common positive design in the course content, then so everybody will have an idea what to expect. You don't need to buy them and then check it out. If you are planning the system, and you can check with the manufacturer, or we're going to have a list there so everybody will know what is the what model number is common negative, common positive design. So this is a common positive MPPT solar charge controller that is matching common positive solar charge maximizing controller. It has to match. As you can see from here, PV positive is bonded all connected to the battery positive terminal, including the inverter here. And internally, MPPT solid charge controller is actually internally connected, and then you do not need to connect that. You could still connect it, but you may not have any current going through it as long as you have a sufficient cable size here to conduct the total current. So this will be system total current. We're still going to introduce how to calculate the current, how to figure out what's the current distribution, but that's the total current we are going to have going through the whole system. And that PV positive terminal do not necessarily to be connected. It will still work because that's like a battery positive is already connected. And you can see here in the common positive design, PS is still going through the solid charge maximizing controller system, but PV positive, it doesn't go through it. Opposite from the common negative design. So this PV negative, you only need a small cable. Could it be just like a 40 amps and to make it a 80 amps this maximum for the MPPT solid charge controller. So this wire, its input of the MPPT solid charge controller is not going to have a lot of current, but positive, these terminals are going to have a lot of current. It's a total current of both MPPT solid charge controller and solid charge maximizing controller. Again, you can have this nominal 24 VDC system going to the solid charge maximizing controller, and then you can have optional second 48 VDC solid charge maximizing controller system built in. You still call them a split wire, but it's split wire like a 1, so it's different voltage. This is another option system. It could work for different voltage system. Also make sure that common negative MPPT solid charge controller will not be used here unless you charge a separate battery bank. We're going to talk about that in another scenario with a common negative, the MPPT solid charge controller used in a common positive solid charge maximizing controller system, but it has to charge a separate battery, like a power pack or something. So the battery positive terminal, negative terminal doesn't get connected into this system, because if you connect that battery into this system, it's a short circuit. It's like a burning. So how you define that? It's a PV positive, battery positive terminal of common positive system is internally bonded. So all this positive terminal of the solid charge maximizing controller, solar array, inverter, and it's all connected. So they have the same voltage in this system. And then how to find them out? We just explained the same way to find out what is a common positive, common negative design. First, we say when the MPPT solid charge controller is not powered, and you check a continuity inside the charge controller between PV positive, battery positive. If you have continuity there, that means this is common positive design. A second way would be checking the voltage. Once you have the system set up, connected, and you check the voltage between PV negative and battery negative, you would find a voltage there. Normally it's a system voltage. It's whatever the battery voltage is, you're going to find that voltage. It's like 26.5 volts normally. So PV positive, battery positive, the voltage will be 0. So you know that is common positive design. Also, another way, you check with the manufacturer's manual book how they suggest this system to be connected. If they're connected in that way, it's a common positive, PV positive, PV battery positive can be connected in somewhere in the same bonded somewhere terminal block. Then you say, okay, this is 100% for sure. It's a common positive design. So another way is like just talk to the manufacturer directly, technical support, ask them which terminal, what kind of transistor they are using inside, what is actually connected inside the terminal. So, but they don't, and like many tech sales, they don't necessarily have that information because they don't know how the device was built. So sometimes that's why we say, okay, if you have a common positive, we find that some small, this EPI-Ever, this solid charge controller, they're actually common positive design. Many of them, the small one, they are actually common positive design. So we would expect if you have any question, not sure if it is common positive, common, again, let us know. We're happy to find out. And then we find out we're going to have a list posted in the course, like a resources content there, so everybody can take a look and can check that and find out what MPPT solid charge controller is positive, which one is negative. So make sure when you have the system set up, make sure it's common positive matches common positive, common negative matches common negative, and that way ensure the system will work properly. We're not causing any shortage. This slide here actually only give you the summarize what we just learned from the previous two slides. For common positive system, it is PV positive, battery positive, bonded, connected inside the MPPT solid charge controller. For common negative design, is PV negative, battery negative is bonded. It's physically connected inside the solid charge controller. So this is what we learned. This is summarized here. For the grounding options, what is ground is not grounded. We can leave this one to another slide. We're going to talk about how to connect the grounding, what can be used to connect to the ground, what can never be grounded. So, but in here we want to mention that PS terminal doesn't matter you have common negative or common positive design. This PS terminal, it's the split wire terminal unique in the solid charge maximizing controller system. It's called a PS. That's the nominal voltage matches the battery bank, and that never going to be connected to the ground, and it always gets controlled by the solid charge maximizing controller. So that terminal has to be left out, not to be bonded. It has to be controlled by the solid charge maximizing controller, and it can never be grounded, because if you have that grounded, once the solid charge maximizing controller open the circuit, you're losing the ground. So that never going to be connected to the ground. That's the rule. PS terminal always connected to the solid charge maximizing controller, SCMC. That terminal always called a PS. So that split wire, PS stand for that split wire. So split wire, that terminals always handle high current capacity, always get connected to the solid charge maximizing controller. So this is the one to remember. You don't want to remember that. But for the grounding, we're going to leave that for the next lecture. So this is the unique application. It's actually a common negative solid charge maximizing controller system, but you have a separate this MPPT solid charge controller over here. It's a separate MPPT solid charge controller. The rest is the same, like what we just explained. It has a large capacity, MC solid charge maximizing controller system, has large capacity and power heavy this DC load with a lithium iron phosphate battery bank. This is typical solid charge maximizing controller, but it's common negative design. We say you could have a common positive solid charge controller installed. However, that solid charge controller must charge a separate battery. So this battery can be a power pack, or small, this portable power pack. You can carry them to different locations, portable. You never want to connect the battery positive to this battery positive. Say, like you try to connect this one, definitely no. You try to connect it, definitely no, because it will not work, because you're going to have a short circuit there. Definitely you cannot connect that. You can have them separate a battery. Say, we found some smaller, this common positive MPPT solid charge controller, Mr. Power, or some like a smaller this amperage. They have the common positive design, and that common positive design MPPT solid charge controller could be used in this common negative system, but it has to charge a separate battery, say like a portable battery, and can be used to charge a cell phone or stuff. But you never want to have this two battery connected together. It's very important, because you check with a voltage meter, you will see, you will surprise, the voltage is so high. So you definitely want to join them together. You're going to cause short circuits. So this is the opposite of the system we just explained. It's common negative MPPT solid charge controller to charge a different battery in a common positive, this solid charge maximizing controller system. The whole system here is actually common positive design, a common positive MPPT solid charge controller in the system to power the DC node directly, has a high current capacity. It has to have a LFP battery with a battery management system, typical this solid charge maximizing controller system. By the way, the diagram shown here, like you don't see any fuses, you don't see any DC disconnect, you don't see like terminals, blocks, high current connections. It's only for illustration purpose. So those components, we are going to talk about them later. But here, you want to see the principle, how it works, and how the system is organized, connected. So in the future, it's much easier for you to connect, to set up the whole system. That's likely to make a mistake. Just a diagram is only principle only, so we don't have the DC, this disconnection shown here, or this fuse is shown here. Just to give you the idea. So you come here that you have common negative MPPT solid charge controller here, but you have a separate battery. This battery can be any type of battery, lead acid or gel, this is sealed lead acid, or any kind of battery. No need to be LFP battery. That battery is portable with a smaller capacity. You don't have a DC load directly connected. You can power a lot of these large inverters, but this is a smaller system, maybe power pack, and like you want to carry it around, the smaller capacity, and you want to connect to this system charged by MPPT solid charge controller, even 12 volt system, even 12 volt, not used in the 24 volt system, because it just is a separate different thing. So it can be used, but you can never connect these two batteries together. So it's very important to understand this. It has to be a separate battery that is not connected to the common negative, the solid charge maximizing controller system, or common positive solid charge. Sorry, this should be common positive here instead of negative. It should not be connected to the common positive solid charge controller system instead of negative. So because it's a negative design, You don't want them connected to the positive system.